Okay, let's talk about translation. Translation is the process of converting mRNA, that's what was just transcribed in the nucleus, converting it to proteins. That is translation. It occurs mainly in the cytoplasm and is carried out by the ribosome. Okay. So let's look at this process. So there are 3 steps in translation. Okay. So the steps are, and big steps are, 1 is initiation. So during initiation, this is when the ribosome binds to the mRNA. So ribosome binds to mRNA. That's the steps of initiation. Then you have the step of elongation. Here, ribosome slides or reads, or ribosome reads mRNA and assembles the protein. That is what's going on during elongation. And then the last step is termination. In termination, okay, ribosome dissociates, breaks apart, dissociates. That's what dissociate, right? Dissociates, and peptide is released. Okay, 3 steps to it. So let's get started in looking at how this works. So I recommend you try to find some animations on this. I'm sure you'll do a lot better job than I'm about to do with my whiteboard, but here we go. So I've already drawn for you a mRNA. So here is the mRNA of interest to us that we're going to translate. And this mRNA, we've kept it simple. It's just GGG Aug. These are the RNA nucleotides, and remember, every 3 of them forms a codon. So we have GGG, which stands for glycine, AUG for methionine, proline is CCC, AA for lysine, UUU for phenylalanine, and so forth. Okay, so I've listed for you the codons in the mRNA and their corresponding amino acids that they code for. Okay, and I've redrawn the mRNA 3 times. So, but I've only listed the amino acids once. All right. So the step of initiation. During the initiation, the ribosome is made in 2 pieces. But one's called a small ribosomal unit and a large ribosomal unit. 2 units. So for initiation, the small unit, or called SRU, I call it SRU, the small ribosomal unit will slide along the mRNA, SRU, until it finds AUG. Okay? So in initiation, ribosome locates the AUG, which is the start codon. Okay, put it somewhere else. So in initiation, ribosome locates AUG, what we call the start codon. So it slides along the mRNA until it finds AUG, and then a tRNA will come in and and form temporary hydrogen bonds with AUG, and that tRNA will be attached to methionine, because methionine is the amino acid that corresponds to this codon. Okay, so once the small unit grabs the mRNA, a tRNA will slide in and form, so of course the tRNA will have a part called the anticodon. So in here to be something like UAC would be the codon, what's called an anticodon on the tRNA, and that will form hydrogen bonds, like XO. So the tRNA slides in and hangs out right above AUG, and then the bigger part of the ribosome, the large unit, comes in, and the large unit has three parts in it. It has a site here, a site here, and a site here. So it has what's called an E site, a P site, and an A site. So when the large unit associates with the small unit, this is the LRU, it does so that the initiated tRNA, the first tRNA, will be in the P site, and the E site and A sites are open. So let's summarize that. So A is ribosome locates AUG. B, initiator tRNA, which is always tRNA that's linked to AUG. So the initiator tRNA binds to AUG, and 3, or C, part C, large ribosomal unit associates with small ribosomal unit, okay, such that the tRNA is in the P site. And these 3 steps, that is what is initiation. So now, first one is SRU finds AUG, second is the initiator tRNA comes in, binds to the AUG, and it brings along with it its amino acid. Remember tRNA's, their job is to bind to amino acids and transport them around the cell. So it comes in with the proper amino acid that's appropriate for AUG, and so it's there. And then the large unit comes in, like so, to form a dimer with its partner, such that the tRNA now is in the P site, and the E site and A sites are open. That's initiation. Then we'll go to the next step, which is elongation. So for elongation, a second tRNA will pop in to the A site. So here, this tRNA will pop in. Of course, it will be attached to the appropriate amino acid for CCC, which in this case is proline. So it'll be attached to proline like so, okay? And once there is a tRNA in the P and the A site, then an enzyme will transfer the amino acid from the P site over to the A site, like so. Transfer it over to form a peptide bond. Like that. Okay? And then the entire ribosome will slide. Okay, so I'll write that down for you shortly. So step 1 is a tRNA enters the A site, then an enzyme transfer the amino acid from the P site over to the A site to form a peptide bond between the amino acids, and then the ribosome will slide. down by 1 codon. So let's do that right here, and then we'll try to come back to it. So here, once you form a peptide bond here, then the ribosome will slide down by 1 base, by one codon, and now the initiated tRNA that was in the P site, now it's there, it's about to fall out because now it's uncharged. The amino acid has been removed from it and put over there. And then this amino acid here, that was here, is still there, but now it's attached to two amino acids. It has protein, and it's also attached to methionine. Okay. And now, because it's split this way, the tRNA that was in the P site now ends up in the E site. And the tRNA that was in the A site is now in the P site. Okay, so again, so you call it EPA. All right, and now that has moved over to a new codon, and now that the A site is open again, then another tRNA will pop in here. Right? And that tRNA that comes in will be attached to the AAA, attached to lysine. And then what would happen is, again, another enzyme, a transferase enzyme, would transfer both of these over to here to form a new peptide bond between lysine and the protein and the methionine, like so. And once this happens, it will slide again down to the next codon and repeat the process. And you keep on adding the chain to the new one, and that way you elongate the peptide chain. That's elongation. Let me see if I can summarize that for you better. So, for elongation, steps of elongation. Here, step 1 is tRNA enters A site. A is always where the new tRNA enters. Step 2, enzyme transfer amino acid from P to A site and forms a peptide bond. Of course, this is believed to be a major role of rRNA, okay, to form this peptide bond. So you're going to have, for example, here you have your protein bonded to methionine. This is your peptide bond that was just formed, okay, by transferring it from P to A. In step 3, ribosome slides by 1 codon, right? And then slide by 1 codon, and then step 4, A site is open to receive new tRNA with amino acid, and then steps 2 through 3 repeat. Then repeat steps 2 through 4 again. Okay. So all you do is you slide, a new one enters, you transfer it over, form a new bond, get longer, slide some more, repeat, slide, repeat, until you get to the last, until you get to the stop codon, which is what we call termination. So let's try to jump to that part. So in termination, okay, so let's work our way down the mRNA, and let's pretend that now we're here at the UGA, which is a stop codon, okay? So here we go. Let's just draw this part of it. So you have your UGA, CCC, before it has CCC as well, okay? So by the time the ribosome gets here, so the SRU is here still, and by the time it gets here, the tRNA that will be in the P site will have attached to it by this point. It will have this one, phenylalanine, linked to proline, linked to glycine, linked to phenylalanine, linked to lysine, right? Linked to proline, and linked to methionine. This is what has happened as it has been elongated along the way, where you keep adding, each time you add an amino acid to the chain, make it longer. So you begin with methionine, the first one, then proline, then lysine, then phenylalanine, then glycine, then proline, then again phenylalanine right here. And now, let's draw off, of course, the ribosome still here. This is the E site, P site, and the A site. So E, P, A. So now, once you get to the stop codon, a protein called a release factor enters that site. So a protein called the release factor enters the site, and that protein will break the bond between the tRNA to release the peptide chain, and the ribosome will dissociate. Okay, so here, for termination, here termination, eventually ribosome arrives at the stop codon. Okay, so when stop codon is in the A site, a protein called release factor binds to a site. All right, that's about 1, 2. Then RF breaks bond between tRNA and the peptide chain. So this R's job is to do this. Cut this right there. Break that bond. And then peptide is released, and ribosome dissociates. Ribosome dissociates and stops working. Dissociates. And okay, so that is those are the steps. You initiate it, make it long, and then you stop it. Okay. Now let's do some of the facts, some of the more information that may be helpful on this process. Let me get this thing turned over right. Who made this work? So, some tidbits about translation some more. So, some other facts. One, multiple ribosomes can follow each other to translate the same mRNA, can translate same mRNA to, again, make many copies quickly of a protein. When they're in that arrangement, it's called a polyribosome. Okay. Two, the polyribosome is there. I can't tell you, but I had something in mind to tell you why I was doing this, but I forgot what I was going to say to you. Okay, well, all right, it may come back, I don't know. So, you can have multiple ribosomes following each other to make many copies of the protein. And two, what was I going to say to you? All right, I've forgotten it. So, that's it. That's translation. So, it's in the cytoplasm, and now you've made your protein, and it can be folded and become functional. So, once you make it in the ribosome, it normally gets shipped into the ER where it's modified some more before it's then packaged by the Golgi to be used in your cell. Okay, we'll stop there.